Good morning, guys. Today we're going to be covering Notes 1.04, Domain and Range Part 2. This is a continuation of the last lesson. Uh, but the objective today, the goal today, is not only will we deal with continuous functions like we did on the last lesson, but in this lesson we're going to talk about discontinuous functions. How would we write out the domain and range for discontinuous functions? And we're still going to use interval notation. That's when you have a beginning point and an ending point. Okay. One thing I want you to remember, just to kind of go back from the previous lesson and talk about domain and range again. And so I always like to think of, domain represents all the values on the x. And remember, we were using that spaghetti stick, or if you have a pencil that you can roll on your page, anything that has like a smooth surface, like a cylinder surface, we were using that to kind of scan through the graph and see what x values does the graph cover. And that's our domain, right? We went from left to right. And I think I was using green, right? So for domain, we were using green, and we made sure that domain was scanning the graph from left to right. And for range, that's when we were scanning from the bottom to the top to take into account all the y values that the graph covers. Okay, so let's look at this first example, and I'm going to break it down into parts. And just like the last lesson, you notice that I have two graphs that are the exact same graph, and I just kind of copied the picture so that we can discuss domain on one side and range on the other. Okay, but again, let's read the instructions. It's always important to read the instructions. Identify whether each function is continuous or discontinuous. Okay, so that's step one. Then step two, write the domain and range for each function using interval notation. So this is kind of similar to the last lesson, but we're going to introduce continuous and discontinuous into the situation. So if I scan the graph, and since it's the same graph on both sides, I can just scan one, right? So question, right? Is it continuous or discontinuous? Can I draw it without lifting my pen? Right? Can I draw this curve without lifting my pen? Yeah, it looks like I can. So I'm going to say that this one is continuous. Oh, let me use blue. Continuous. Okay. Now for domain, right, we were using green. And again, if you have like a spaghetti stick or a pencil that you can roll across the page, and we were rolling this across the page. And this is domain, right? We're scanning all the x values. This is -6, -5, -4, -3. And so we're kind of scanning through even the decimals, right? Every value. And what does the arrow mean again? Like from the last lesson, right? It means that this line is going to keep going, right? Infinitely to the left, and this arrow means infinitely to the right. So the graph starts or exists all the way to -infinity. So -infinity. And do we put, do we put a parentheses or a bracket? Right, we have to remember that for infinities, we're going to put parentheses. And so this is infinity is negative infinity is where it starts on the left, and what's the farthest to the right that the graph will go? So if I'm scanning, what does the arrow mean, right? Towards infinity. So all the way to the right towards infinity. So, and for infinities we use parentheses. Okay, now let's look at the range. And remember, the range, we were looking at it from bottom to top. So I'm drawing, a horizontal line, and we're going to scan this way. Right? When do I start touching the graph? Looks like at this value, right? What is this value? Let's count it to make sure. It's 1, 2, 3, 4. -4 is where the graph starts. And we have to figure out, should I put a parentheses or a bracket? And the question is, at this point of the graph, is there a hole or is it closed? And it looks like it's closed, right? If I move the stick out of the way, yeah, it looks like it's closed. So I'm going to put a bracket. Okay, and then we're going to keep rolling this horizontal line. And so our starting point was -4, and as we're going towards the top, how far up does the graph go? And the arrows mean infinity, right? So it's going to go way past the drawing, right, towards infinity. So we're going to put infinity as our endpoint and parentheses for infinity. Okay, let's go to the second example. Okay, so looking at this graph, is it continuous or discontinuous? Right, if it's continuous, then I can draw it without lifting my pen. So I haven't lifted my pen. Yep, I can draw it without lifting my pen. So it must be continuous. So we're going to go ahead and write that here. Continuous. Okay, then we're going to look at domain and range. So again, we can take out, if we're using, spaghetti stick or a pencil, and we're going to roll this across the page. And so the starting point looks like a -6. And should I put a parentheses in front of the -6 or a bracket? And since it's open here, that means that we're not really, at -6. We're very close to -6, but there's an opening there. So we can't put a bracket, but we can definitely put a parentheses. So we're going to put a parentheses in front of -6. And so we're going to keep moving our stick and scanning, right? And checking to see, right, as I'm scanning, am I continuously hitting the graph? Yes, right, we're hitting the graph here, for example. As I'm moving along, we hit the graph here, for example. So as you're moving your stick, check to see if we're still hitting the graph. So I'm still hitting the graph. And my ending point, there's actually a point there, it's closed, is at +6. +6. And I'm going to put a bracket because the circle is closed. So on -6 over here, I put a parentheses because it's open. So I'm going to put a reminder there that I put parentheses because it's open. And here I put a bracket because it's closed. Okay? So just to remind me on that point. All right, now let's look at the range. We're going to get our stick and then draw a horizontal one and start scanning. All right, so here, as I'm scanning, remember, start from the bottom and scan to the top. What's the lowest point? Where do I start hitting the graph? At what number? And it looks like -4. Let's check. 1, 2, 3, 4. -4. So my starting point is going to be -4, comma. And we should notice that at -4 at this location, there's an opening. So if it's open, we're going to put parentheses. So we put parentheses because there was an open circle. All right, and so let's keep moving our stick or our pencil. As we keep rolling it and rolling it, we're still hitting the graph. Remember, we're not concerned at this point, we're just scanning. We're not concerned, like for example, at this location, I'm hitting the graph 3 times, for example. But we're not concerned with the vertical line test right now. We're concerned with domain and range, right? So as I keep scanning, when do I stop hitting the graph? Right about here. And what value is that? Let's double check where that is. 1, 2, 3, 4, 5. So at 5 is the last time that I make contact with the graph, and I'm going to put a bracket because it's closed. This part of the graph, there's no holes here. It's closed, so I'm going to put a bracket. All right. Example 3. Example 3. Right. So let's check to see if it's continuous. So can I draw it without lifting my pencil or pen? But at this point, there's some sort of hole there, right? So I have to lift up my pencil and then start and continue, right? So if I'm drawing it, this location, this hole, the location of this hole is causing me to lift my pencil. So it's discontinuous. And what's the location of this hole? It looks like it's at -2. So keep that in mind. So there's a hole. And if there's a hole, that means it's discontinuous. Okay, I'm going to zoom in, and what I want to focus on is this one. And so here I'm going to focus on domain first, then I'll talk about range. But you can go ahead and get your spaghetti stick out, and so I'll get line. And to save space, I'm going to write my domain underneath the space because I feel like I need more space. Okay, but we're gonna see where does this stick go, right? So remember, domain is going from left to right. So this arrow means negative infinity to the left, right? Oh, sorry, we're gonna write it underneath, right? So negative infinity, parentheses, because we're using infinity. And then what happens as I move the stick towards the right, because we want to know how far to the right the graph goes. But what happens as I'm moving along, and then I come up to this hole in the graph. So that's kind of like my stopping point. So I'm going to have to do two intervals, two sets of parentheses, because the graph is divided into two pieces, right? This piece on the left side and then the piece on the right side. So because there's, two pieces, I have to figure out where my first piece ends. So my first piece ends at -2. My first piece ends at -2, and I'm going to put a parentheses because it's open at that location. It's open because there's a hole, right? All right. So this part of the interval is responsible for that piece on the left. Okay. So now I need to talk about the piece on the right. This piece. But I'm going to put a union to say that we're going to, combine these two pieces that make up the graph. But now let's talk about the piece on the right. Where does that piece start? Well, it starts where the other one stopped, right? So -2 is going to be our starting point for the second piece. And again, I'm putting a parentheses because it's open. A reminder again. And then the second piece, as I'm scanning, how far to the right does it go? Well, it has an arrow going towards positive infinity, right? Because here it's at x equals 4, x equals 5, x equals 6, and it's going to keep going towards positive infinity. So I'm going to put here positive infinity, close parentheses. Okay, so this is my domain. And so what it's saying is that there's a piece of the graph that goes from negative infinity to -2, and then something happens where it has to break off into a second piece. That second piece starts at -2 and continues to the right towards positive infinity. So yeah, so it's talking about this graph that it's broken into two pieces. The piece goes from negative infinity to -2, and then the second piece starts at -2 and goes to positive infinity. Okay, so that's for the domain. Let's look at the range. Oh, sorry, let me delete this stick that we used for the domain. Now let's look at the range, and we're going to look at purple. So you would take out your spaghetti stick, and we're going to do a horizontal scan. And so how far to the bottom does the graph go? Well, the arrows say that it's going to go towards negative infinity. So I'm going to put negative infinity, parentheses. Then I'm going to keep moving the stick, and I'm still hitting the graph. I'm hitting the graph. And I'm hitting the graph here, right? Because even though there's a hole here, I'm still hitting the graph here. So there's no gap in the range. There's that at 1 it's still covered. We're still covered, right? And then I keep scanning, And the graph ends at positive 3, it looks. 1, 2, 3. Yeah, positive 3. So I'm going to put comma, positive 3. And it looks like it's closed at that highest point. So I'm going to put a bracket. Okay. Let me go ahead and delete the spaghetti stick. Oh, actually, let me just leave it there for now. Let me delete it. There we go. All right. So the thing I wanted you to see is, right, if we have a discontinuous function, we have to figure out where does the gap happen, if it happens at all, right? Here, as we were scanning from left to right, there was a gap, a hole here. But when we were scanning the range, we were scanning from the bottom to the top, and we didn't find any hole, but there was a starting point, the lowest point it was towards negative infinity, and the highest point was positive 3. Okay, now let's look at example 4. Well, this one should be obvious if it's continuous or discontinuous, right? Because if I'm drawing, I have to take my pencil off to start the next piece, right? So clearly it's discontinuous. There's a huge jump right here. So we know it is discontinuous. Right. And let's look at the domain. So we would take out our spaghetti stick and put it vertically. And we're going to start scanning. And when is the first location that I make contact with the graph? Well, there's an arrow there. So that arrow means that the graph goes towards infinity. And what's to the left, right? Negative infinity. So I'm going to put negative infinity. Oh, sorry. I'm going to write it at the bottom again because I'm going to need space. Oh. Okay. Sorry about that. Yeah, I'm going to write it at the bottom. Negative infinity. Oh, and we're using green, right, for domain. Okay, and then we keep scanning. So negative infinity, and then we keep scanning towards the right, towards the right. Oh, what happens here? Right? Does it hit the graph or not at this location? Well, there is a hole here, but at the same location there's a point. So if I scan with a vertical line through here, it does hit the graph. So the graph does exist, right? The graph exists here, exists here, exists here, here, here. And then when I get to this point, the graph still exists because there's a point. Okay, so for domain and range, I'm just looking, where does the graph exist? Okay, so let's keep scanning. Scanning, I don't see any openings, any openings. Nope, nope. And then we end right here at an opening. So we end at 1, 2, 3, 4 on the x. So I'm going to put 4 and parentheses. And again, why did I put parentheses? Because it's open there. We put a parentheses because it's open. Okay, now let's look at the range. So now we're going to put our spaghetti stick horizontal and then scan from the bottom to the top. Okay, so as I'm scanning from the bottom, I have an arrow, that means it's going towards negative infinity. Oh yes, I'm using purple, right? And then negative infinity, I'm hitting the graph, hitting the graph, hitting the graph, hitting the graph. Whoa, there's an opening where I'm not hitting the graph anymore. Where does that opening occur? It looks like at -2. So -2 with a parentheses. And again, I put parentheses because it's open. All right. And then I'm going to put union. So I'm kind of telling the reader that I have two pieces that I'm going to describe. Okay. So that's the end of that piece, right? Where does the second piece start? At which y value, right? This is -2, -1, 0. The graph continues at 0, so that's going to be my next section. It's going to be 0. And is it a closed or open location? It's closed. So I'm going to put a bracket. I'm going to put a note for myself that I put a bracket because it's closed. Comma. So the second part of the graph, second part of the graph continues, right? So it starts at 0, and I'm hitting the graph, hitting the graph, hitting the graph as I keep scanning up. And where does the graph, that piece end? It looks like it ends at 1, 2, 3, 4. It ends at 4. And it's open at 4, so I'm going to put parentheses. And I'm going to put a note for myself that I put parentheses because it's open. Okay. And again, I just want to mention, since this is a video, you can't really ask me questions right now, but next time we meet as a class, if you have any questions that you want to clarify, why we did certain things that we did in the video, you can bring those up during class. So let's go ahead and move to the next example, example 5. All right, so sorry, we're continuing to number 5. Number 5. Okay, and so is this one continuous or not? So as we're scanning, I don't see any holes, any jumps, any asymptotes. So it looks like this one is continuous. And we're going to find domain and range. So go ahead and take out spaghetti sticks and doing green for domain. All right, so as I'm scanning, what's the left, how far to the left does the graph go? It goes towards negative infinity. And how far to the right does it go? I know it's going to be continuous, so there's no areas to worry about. We just need to know the end point, because we're going to hit the graph all along this region, and then our last point on the right, the farthest point on the right, it looks like it's 6. Let me double check. 1, 2, 3, 4, 5, 6. And we're going to put a bracket because it's closed. It's a closed circle. All right, and then let me go ahead and delete this point. Oh no, okay, no, let me go ahead and draw the horizontal line. Okay. And so this one we're going to scan from the bottom to the top. And so as we're scanning, the first time we make contact with the graph is at what y value, right? Because this is -1, this is 0, this is 1, 2, 3. But where do I start making contact with the graph? And we should agree that it makes contact at y equals 0, right? 0, and it seems to be closed at that location, so I'm going to put a bracket, comma, how high does the graph go? Well, we might be tempted to say that it goes as high as 5, right? That's 1, 2, 3, 4, 5, 6, sorry. This point is at a level of 6. But that's not where the graph ends, because if we look at the other side, there's an arrow. And so it's kind of like a trick question. You know, most students are going to say that the graph ends at 6, right? That's the highest that the graph goes. But no, it actually goes higher because of this arrow. It will go higher because of the arrow. See, the arrow goes above it, and it means that it's going to go towards positive infinity. So it's going to keep going. So positive infinity, close parentheses. Wait, yeah, parentheses. Oh, and I'm going to put a note at the 0 here. We put a bracket here because it was closed. All right, so let's go to example 6. Okay, example 6. And then after example 6, there's one more. So a total of 7 examples for today. Oh yeah, let's figure out if it is continuous or discontinuous. Well, you know, if I see these boundaries, remember these are called asymptotes. Since I'm looking at these, I see that the graph is divided into how many pieces, right? How many blue sections? I see one section over here, that's one piece, and then one section over here, that's the second piece. So, because the graph is broken up into 2 pieces, I can already tell we're going to have a discontinuous situation. Discontinuous situation. Okay, so let's look at domain and range. So domain, let's put it vertical, right? And domain, we're going from left to right. Okay, so how far to the left? Well, there's an arrow, so that means towards negative infinity. So I'm going to write that on the bottom so I have space. So negative infinity. Then we keep moving towards the right, towards the right, towards the right. And I'm hitting the graph, hitting the graph, hitting the graph, right? All along this point. But there's this gap that happens right around here. Right around here. So, right, this is -6, -5, -4, -3, -2, -1, 0. At 0. Right, happens at 0. So, put 0 there. And is it open here or is it closed? Remember we mentioned something about that the graph doesn't touch here. So it's actually open there. So we're going to use parentheses. And we're using parentheses because it's open. And then we're going to put a U to continue because there's another piece that we need to cover. And so this next piece that we're going to cover is, right, it starts at 0. So the left piece ended at 0. The piece on the right starts at 0. So that's usually what happens. Usually wherever it stopped, wherever the last piece stopped, then the second piece starts at that point. And so we keep scanning, going towards the right, towards the right, towards the right. How far to the right do we go? We go towards positive infinity. And then parentheses. And just a reminder here, we put parentheses here because it was open. Now let's look at the range. And so we're going to draw, or we're going to use our spaghetti stick but horizontally. And so we're going from bottom to top. What kind of looks like the same situation, just going bottom to top, right? So this arrow means that it's going to go towards negative infinity. Comma. And then keep scanning, we keep scanning, we keep scanning. And the graph breaks up at 0. Parentheses because it's open. And then union, where does the next piece start? This next blue piece starts at 0. So I'm going to put 0, comma. Where does it end? As I keep scanning up, I keep scanning, scanning, scanning. The arrow here means I'm going to keep going towards positive infinity. There we go. Okay. Now let's look at example 7, the last one. All right, so let's see. Is this continuous or discontinuous? Well, it doesn't look good, right? I see a hole and I see a jump. So we already know it's going to be discontinuous because we see a hole and we see a jump. Domain, range. So we're going to get our, wrong color. I like to kind of color coordinate so that it kind of stays consistent in the examples. And so we're going to scan from left to right. There's an arrow. So just keep in mind, if there's an arrow, that means it's going to go towards infinity. You just have to decide, is it positive infinity or negative? Well, if I keep going to the left, these values are negative, right? The x's become negative as I go towards the left. So it's going to be negative infinity, comma, keep scanning, I keep scanning, I keep scanning. And then there's a hole here which causes the graph to break up into another piece, right? So where does that hole end? Where does that hole appear at? What value? It looks like it appears at -2 on the x. And I'm going to put parentheses. Why do we put parentheses here? Because it was open. Okay. Then I'm going to put the U symbol, meaning union, right? There's two pieces that we're going to put together or unify. And so the next piece starts where the last one finished, right? So the last piece finished at -2, then there was a hole, and then the graph continues, but continues at -2. So wherever the hole was, that's where it continues at. And so I'm scanning, I keep scanning, I'm at -1, 0, 1. Huh. Am I still hitting the graph at 1, at x equals 1? Yes, right? I'm hitting it right here. So the graph still exists. Even though there's a hole here, I'm still hitting the graph here, so it still exists. All right, so let's keep moving. Keep moving, and I'm still hitting the graph, hitting the graph, hitting the graph, hitting the graph. And the arrow means I'm going towards positive x values, positive infinity. So positive infinity. All right, and the range. So let's put the spaghetti stick horizontal. Then we're going to scan from the bottom to the top. As I look at the bottom, there's arrows. So arrows mean infinity, right? But since we're scanning on the y, remember the y's are negative down here, so it's going to go towards negative infinity. And then we're going to keep scanning, 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 scanning. Oh, what happens here? Well, there's a hole, but I still hit the graph. So the graph still exists at y equals -1. So it still exists because I'm hitting the graph here. Okay, so even though there was a hole, I'm still hitting the graph. I'm still hitting the graph, hitting the graph. I keep scanning, scanning. I hit the graph here. I keep hitting the graph, hitting the graph. I have another hole, but that hole is covered because I'm still hitting the graph over here. Okay, so I can still keep going. And the highest point that I reach is at 3. 1, 2, 3. And I'm going to put a bracket. And why do I put a bracket? Because it was closed. That point is closed. All right, that brings us to the end of the notes. Again, if you have any questions, make sure to bring them up next class, and I'll be sure to clear up any parts that were confusing or anything that didn't make sense. I'll be able to clear it up in class. But thank you for joining me for this video. I'll see you guys next time in class.